Today's lesson is on geometric sequences. This is chapter 12.2. Your learning target for today is I can recognize if a sequence is geometric, and I can use the formulas to evaluate for missing information. So here we have two sequences, and it's asking us for the next term. In order to find the next term, we're going to compare these numbers and come up with patterns. So from 1/3 to 1, we're multiplying by 3. From 1 to 1/3, again, that pattern continues of multiplying by 3. So in order to find the next term in this sequence, I'm going to take 81, I'm going to multiply that by 3, and I'm going to get 243. Now for our next sequence, I'm going to compare 1024 to 256, and this is multiplying by 1/4. Same thing, between 256 and 64, you're also multiplying by that 1/4. So to find our next term, I'm going to take 16, multiply it by 1/4, and the next term in this sequence would be 4. Now, so a geometric sequence is a list of terms whose ratios of successive terms, which just means previous terms, is a constant called the common ratio. So that's what we just found in those last two sequences, meaning that those were both geometric sequences. So now, how to find r? We have this r equals an over an minus 1. What that is we're just taking some term from our sequence, and we're dividing it by a previous term, or the term previous to that one. Now, it says, is the sequence geometric? If so, find the common ratio. So, in order to find out if this is geometric or not, we're going to pick a term, we can pick any of these four, and divide it by the previous. So I'm going to take -1/2, divide it by 1, and that gives me -1/2. Now I can't just assume that's my r, I need to make sure that this is a common ratio between all terms. So I'm also going to take -1/8 and divide that by 1/4, which will in fact give me -1/2 as well. So now, since it's a common ratio, I know, yes, this is a geometric sequence, and my r is that -1/2. This next example, we have 21, 4.2, and 0.84. I'm going to start with 4.2, and I'm going to divide that by 21, which is going to give me 1/5. Now, I'm going to make sure this is a common ratio, so I'm going to take 0.84, divide that by 4.2, and that is, in fact, 1/5. So this is, yes, a geometric sequence, and my r is 1/5. Now, our last example, we have 5, 10, 15, and 20. In order to have a common ratio, that means what we multiply by is the same. From 5 to 10, we're multiplying by 2. From 10 to 15, are we multiplying by 2 there? No. So this is not a geometric sequence. Now we have explicit geometric. This is to find the nth term. So any term further on in our sequence, our a to the n is our final term. So that term that we're looking to find, our a1 is our first term of our sequence. Our r is that ratio which we multiply by. And then the n is the number of terms in our sequence. So, like I said, this is to find the nth term in a sequence, and then you have recursive geometric, which is to find the next term. So, if we are looking for the 6th term and we have the 5th term, we can use this equation, an equals r a to the n minus 1, because we're just taking that 5th term, multiplying it by the ratio, and then we'll get the 6th term. But in a case like this example, we have 1/4, 1/2, 1, and 2. It wants us to find the 17th term. We can't use recursive geometric because we don't have the 16th term. So what we need to do is we want our 17th term. our first term is 4. We're going to multiply that by our ratio. And then it's going to be to the 17 minus 1. Now, our rate, I'm going to take this 2, I'm going to divide it by 1, and my rate is 2. So, I'm going to simplify this to 1/4 times 2 to the 16th, and this, when you plug it into your calculator, is going to give you 16,384, and that's our 17th term. Now, we're going to continue to use that equation, our AN equals A1R to the N minus 1. This problem gives us our first term being 3/4, our ratio of 4, and it wants us to find the 6th term. So, we know we want a to the 6th, that's what we're solving for. Our first term is 3/4, our ratio is 4, and since our N is 6, this is going to be 6 minus 1. This simplifies down to, you can keep that as a fraction or change it to a decimal, times 4 to the 5th. Now this is going to give you 0.75 times 1,024, which equals 768. So 768 is the 6th term of that sequence. Now, on the other hand, we're given our ratio and the 4th term, and it wants to know what is the first term of this sequence. So, our N is 4 here since we have the 4th term. So that means we start with 2. We're looking for our first term. Our rate we know is 1/3, and our N is 4, so we have 4 minus 1. This leaves us with 2 equals a to the first times 1/3 to the 3rd power. I'm going to keep simplifying this down, which gives me 1/27. Now, in order to get my A1 by itself, I'm going to multiply both sides by 27. And 27 times 2 is 54, which is the first term of my sequence. Now, a geometric mean. This is the terms between any two non-consecutive terms of a geometric sequence. So, for example, it says write a sequence that has two geometric means between 128 and 54. Now, when it says two non-consecutive terms, it means the terms that they give us are not one after the other. So we're starting with 128. We have two geometric means, and then 54. Now, one thing that's helpful is we know we have 1, 2, 3, 4 terms. So our n is 4, and now we can write an equation. At a to the 4th, we know that would be 54 equals our first term is 128. We need our ratio, and then we have 4 minus 1. Now, anytime you're solving a problem like this, you should find your r. That'll help you solve for those two missing terms. Now, as we simplify this, we get 54 equals 128 times r to the 3rd. We're going to divide both sides by 128. We'll get 0.4219 equals r to the 3rd. In order to get rid of r to the 3rd, we're going to take the cube root of 0.4219, giving us a ratio of 0.75 or 3/4. Now, however you write that doesn't matter, but we're going to use that ratio now to find our missing term. That means when we start with 128, we're going to times that by 0.75, which will give us 96. We're going to times 96 by 0.75 to get 72. And now these two answers are our final answers. Those are the two geometric means between 128 and 54 in that geometric sequence. Now, if you need to go back at any point and rewatch certain parts of this video, pause it so you can take it and take down the notes. Be sure to do that. This is your homework for tonight. It is posted as a PDF on Schoology as well. It's page 771, number 17 through 21, only odds, and then 26 through 36. Tomorrow we're moving on to sequences.